Hey, Kimberly, we got the chat all fired up, ready to talk with you. Tell them about yourself.
Hey everyone, good afternoon. I'm Kimberly Medea. I'm responsible for SageMaker product marketing. I've been with AWS 5 years. I started on the IoT team and then moved over to SageMaker. And I work very closely with Sham, so I really enjoyed seeing all the great work that he's been doing with Canvas.
Yeah, that's a super cool service. I wasn't deeply familiar with Canvas prior to this session, actually. So it was really cool to see how simple it is, actually. But we're here to talk about geospatial data today, right?
Data.
Yeah.
That's right, geospatial data. It's out there. One of the things I find really interesting about geospatial data is it's actually estimates vary, but it's anywhere from 40 to 60, 80% of data today actually contains geospatial data. But we haven't been able to really use it effectively to drive insights and make predictions until now with the new geospatial support in SageMaker.
Right.
I
That's
love
a much higher number than I would have guessed at, frankly.
Yeah. Well, I think about, how many times we have our phone, we take a snapshot, that data is proliferating everywhere, more and more. One couple of challenges with it are you have to really have a strong visualization capability to be able to use the data. Also, you want to be able to look at the predictions that you're making on a map to understand them. So, in a little bit, we'll get to the little demo, but I'm going to focus a lot on the cool visualizations and how you can look and explore and play with this with data on the map. And
Then you've
SageMaker's
got my
been,
attention.
yeah, I get to follow, we're following a theme of SageMaker today, right? With the no code, easy machine learning with Canvas, and then with
Mhm.
the new geospatial capabilities, we're going to focus a lot on the interesting visualizations.
So I guess maybe we should take a step back and think about. I mean, that number was a surprise to me, but now that you've said it, it kind of, I guess, makes sense. But what are some of the common use cases around for geospatial data? Certainly when it applies to like machine learning.
Yeah, and we could probably just spend the whole next 20 minutes
yeah.
brainstorming and
Probably.
thinking about cool ways to use geospatial data. I know I heard from a friend of mine this weekend about we were just walking and talking about uses of ML and imagine like tagging or smart collars for animals so they wouldn't get lost and you could kind of track them by their collar. And so there's all sorts of use cases, but I just wanted to kind of cover a few that I've been hearing a lot from customers that I've worked with. First is around monitoring climate change and
Oh,
sustainability.
yeah.
So with geospatial data and imagery, you can track deforestation, look at biodiversity, look at methane gas emissions over time to help shape public policy and corporate policies so that we can all support a greener planet and focus on sustainability. Another use case has been for urban planning and not a non a public sector account. So think about as we build new cities or revitalize existing cities, where do we want to put green spaces? Where do we want to put parking complexes? Thinking about living conditions, where do we want to put these things so that it's accessible? We're building as much green space as we possibly can and reducing emissions in urban settings. So urban development is another really cool, interesting area. For retail as well, thinking about where to put a retail establishment, both in terms of traffic, foot traffic, where you're going to get people to do some window shopping and come in. Also thinking about strategic investments where you build relative to competitors that might be in the area. And then also for insurance, thinking about claims processing, fraud detection, figuring out how insurance companies can best provide for people who are experiencing hurricanes or floods or other natural disasters. So geospatial data is a common theme used throughout all of these different and quite diverse different use cases.
Yeah, that makes a lot of sense, and it presents a unique challenge too when working with that type of data. As you already mentioned, it's got very uh, unique characteristics. It doesn't really make sense to have geospatial data just as geospatial data. It has to be put into the context of where it is, right? And what's surrounding it too, right? That I imagine causes some unique challenges as well, where I need the contextual space of, yeah, I know where this is located, but what's around it, right? Is that something that you see as part of something that SageMaker helps with as well?
Yes, you're teeing up the demo very nicely because we're going to show some points of interest in this disaster relief demo that we're going to show, and we have integrations now that we announced at reInvent with third-party providers and open source providers like Foursquare, for example, so that we can put those points of interest on a map. In the example we'll talk about in just a few minutes, I'll show things like hospitals or emergency relief centers or even things like monuments. All of these things, you really need to have to be able to make an insightful and thoughtful prediction. And one of the biggest challenges that we're trying to help customers with is just accessing those diverse and different kinds of data sets. Whether you have them on your own, you've been collecting them, whether they come from sources like Planet Labs or open source providers or others, that we want to make that all very easily accessible. So within SageMaker, so you don't have to spend the time or the cost to acquire the data sets and work with them. So that, yeah, definitely getting that access to all the diverse kinds of data and making them usable. Things like Sentinel-2 data, Landsat 8 data, all of these things we want to be readily available. And then also in SageMaker, we've been working on building in pre-built data operators as well. So you don't have to do a lot of the tedious coding tasks that you might have to do otherwise, like changing a latitude and longitude coordinates into a street address. We also have the flexibility where you can bring your own model, but we've also built in models for geospatial that you might want to take advantage of again to help you get to that insight faster. And the visualizations is another point, and it's not only visualizing as you're exploring and learning about the different data sets, but it's also after you have a prediction, you want to be able to look at that on a map, and especially as you're working with other stakeholders like city planners or retailers or operations leaders or insurance companies. It's going to be really important to visualize and look at that in the context of the map.
Yeah, I'm glad you brought up like operators on the data, because I was going to ask you about the data formats, I guess, and what you could do with it. I remember a few years ago on the news blog, I wrote a post about the addition of geospatial data into Amazon Redshift, right? And that had some operators inside there. So I was kind of curious, like, once I get this data inside, apart from visualizations, like what can I actually do like with that data? So you say there's a bunch of like built-in operators.
Yes,
And
there's a bunch of built-in operators for common tasks that you could do. So you don't have to redo them over and over. Like I said, translating from the latitude and longitude coordinates into street address, normalizing the data set so that it has the same format. So all of the kind of data munging tasks that we do for tabular data sets, we can take care of that in the context here with the geospatial. So it really saves a lot of time.
Should we go take a look at this demo?
Yeah, I was about to say, Kimberly.
I'm itching to see these visualizations.
Yeah.
Okay, sure. So thank you. Let's have a look. So before we dive into some of the visualizations, I just wanted to take a step back and maybe define, so you're clear what I mean when I say geospatial data. And roughly, we're categorizing this as two different types. First is aerial and satellite imagery, and this represents a geographic data as a matrix of cells. That each contain an attribute value. So it could be things like digital pictures, scanned maps, or even street view imagery. You can see we have an example here on the slide. And the other kind is mapping data. And these are data structures that represent specific features with attributes on Earth. So you mentioned earlier things like points of interest, roads network, GPS traces, all of that. All of this information we're calling geospatial data.
Okay.
And that's usually what is of interest when you're trying to make predictions, right? Is like what's around what I'm actually looking at. Just having a point on a map isn't always that useful.
That's exactly right. Precisely. Okay, so what I'm going to do for this demo is I'm going to show an example of how data scientists can help first responders on the ground after a natural disaster has occurred. In this case, a flood. So to build my model, what I need to do is, we talked about this on the previous slide, is going to be able to access geospatial data. And now this is readily available in SageMaker. So I don't have to spend the time aggregating the data from different sources. I just select the data I need. We showed the screenshot there. In this case, I'm going to pick open source satellite imagery from Sentinel-2, and I'm going to just really zero in on the affected area from the flood. And it's To make it easy to understand where the water has spread, I'm going to go ahead and apply. We talked about the built-in models. I'm going to go ahead and apply the land use classification model in this case, which is one of the ones built into SageMaker. And what this model does is it classifies the land as having water or not having water on it. And looking at the images here before and after the flood, I can clearly see how the water has spread across the region and where it caused the most severe damage. So it's showing that here. And then knowing where flood waters are spreading is definitely very helpful. But what I want to do now is I just want to zoom in and see very clearly if the roads in the area still exist. And I can use this information to help route first responders so they can navigate to people who need help safely. You know, we wouldn't want to send those first responders into a place where there's blockages. We want them to be very helpful, be helpful to them as they work on the ground.
Well, presumably this is also relevant for first responders trying to get to medical facilities, routing them around obstructions.
Absolutely correct. That's absolutely correct. A very good point. And now what I'm going to do is I'm going to add some higher resolution satellite images. This is coming from Planet Labs, and just one of the Planet Labs is just one of the many third-party data providers that are now supported in SageMaker. And you can see the visualizations. Oh, yeah.
Sorry, we had a quick question from chat about how frequently does the geospatial data update, and I imagine that is dependent upon the source of data that you're using, right?
That's a very good question. That's 100% correct. It's based on the data providers. That's correct, in the data source.
Cool. Sorry to interrupt.
Oh, no, thank you. Thank you for the questions. And these visualizations allow me, as we said, to overlay the roads on a map so I can easily identify which roads are underwater, and I can keep those first responders up to date, you know, as conditions are unfolding. Now, I understand my data, and we had a bit of a chance to look at it and understand it. I want to start to make a prediction. And with SageMaker, I don't have to spend a lot of time iterating on the best model for the data set, which can take weeks or more. I'm just going to select one of the pre-built algorithms in SageMaker that we saw. And in this case, I'm going to do road extraction, which greatly accelerates my efforts to train the model in SageMaker. And so I can send directions to those first aid teams on the ground. And then once my model is ready, I can start to make the predictions. And the model in this case is going to identify which roads are intact and not underwater. And using the visualization tools in SageMaker, I can view the predictions on this interactive map, so I have full visibility in what's happening on the ground. And the ones in red are the ones that are flooded and covered with water, but the green ones are still viable, and they're going to be safe to drive on.
Ooh.
And then similar to the satellite data from Planet Labs, I can also add, we talked about this earlier, perfect tee up points of interest data from, in this case, I'm going to pull this data from Foursquare. And so I can see nearest hospitals, medical facilities, and airports. And you can see in this case that there is an airfield on the left side that is surrounded by water, so I probably don't want to direct my teams there. Instead, I'm going to use the temporary helipad or the airport on the right-hand side because that looks better. So this is just a very small taste of how you can visualize and use some of the pre-built models and the data sets that come in with SageMaker in the case for helping with emergency relief.
I mean, I could even see this being useful. So I'm from Houston, and this is a very real problem for us in Houston with the hurricanes that hit Houston. I could see this being useful for drivers as well that are not responding to emergencies, because oftentimes it's difficult to tell how flooded a street is, and you will drive your car down the street and it actually is much more flooded, and you have to abandon your car because it's stuck. So, you know, having this type of information or predictions around, like, no, these are historically streets that we know get deeply flooded, even though if they don't appear to be flooded, you can help drivers avoid those streets during one of these hurricanes, or the aftermath of the hurricane, rather.
Yes, and I'm in the San Francisco Bay Area, and it would be very timely right now with all of the rains that we've been receiving over really, you know, since the new year. We've had so much rain. It would also be helpful for us right now.
I
Totally.
can also see a use case where you have this generally over a period of time. We're like, okay, if you've got these models analyzing this data, now we can predict which streets are likely to flood in
Yes.
a weather event, right? So therefore, we can close those streets off or those areas off or evacuate those people earlier and not have the problem like you just mentioned, Ian, where you're driving down a street and there's water on the roadway. Do I go through it or not? Let's not put people in that situation, right?
And that ties back to the earlier discussion we had around insurance providers and assessing risk and helping them process claims efficiently and make sure they're giving the right care to people too. So it really builds to this whole ecosystem from consumers to insurance companies to public policymakers. It's really quite powerful.
Yeah.
I think I already probably know the answer to this, but I'll ask it anyway. And I think it'll be the classic answer of it depends. But do you see customers, who are using geospatial data and making predictions based off it for their use cases? Do you see them looking at more of the historic data in a geospatial problem? Or is it more of like we had a question earlier, is the satellite geospatial data coming in live? Or do you see a mixture of both?
Yeah, you're right. It is a mixture of both. The example that we just showed with the sustainability uses more of the historic, and I actually have one other example from a customer who presented with us, BMW, which I'll share a little bit more in
Oh,
detail
cool.
about. They also use historical. That those are the ones that I've been working with, but I do think we're just getting started here, so you will see the mix.
Okay, makes sense.
And I just wanted to give one other example that I thought was kind of cool, related to using geospatial data. And this is based on some work that many of our customers have done. We had BMW share their story with us at reInvent, and just wanted to give another example of thinking about sustainability, particularly in urban areas and urban cities, to help fight climate change. So around 60% of the world's population actually lives in cities and urban areas today, and that's actually where 70% of the greenhouse emissions are generated. So there's some really low-hanging fruit and great potential to focused urban planning and to assist city planners in urban areas. So things like being able to predict as new traffic regulations open up. How will that impact EVs, and how will we get more EVs on the road as a result of this regulation so that we can reduce traffic and emissions? So sitting down earlier on as regulations are being planned and looking at their impact on emissions is another cool area we've seen. We can also think about identifying areas that have insufficient charging infrastructure by looking at the commuting time between destinations and charging stations, and help plan where we want to build the next charging stations. And also working with public policymakers on thinking about prices of parking spaces and parking in general, where we're going to build parking lots, and how that will change driver behavior so that we can understand mobility and routing and emissions based on those policies. So just a couple of examples. And I just wanted to share how you might go about using SageMaker to address some of these challenges. So just another quick little visual here.
Ooh.
To address these problems, one of the customers we've been working with is BMW, and we started with an anonymized raw set of GPS data, and that was where vehicles were driven in park. So the point earlier, this is some historical data about cars driving patterns and where they park, and then we converted the GPS traces into routes using map matching, kind of as we have in this visual here. And then if you can think about it, if a route were a sentence, then the landmarks along that would be the words in that sentence. So we use natural language processing model to predict which routes were likely to be taken by EV drivers.
Oh,
And then in parallel, working with the team at BMW, where they built a second model to cluster the vehicle parking locations to predict where EVs are likely to be parked, and for example, near the charging infrastructure. And then finally, they merged the two models to triangulate the predictions. And at the end of the training, the model was capable of predicting how likely It is for specific fleets to convert to EV, and it was pretty accurate in that case. So this is another kind of complex example of a lot of different things coming together to be able to generate that prediction. And I just wanted to comment on a couple of the additional capabilities in SageMaker that helped use cases like this come to life. And it's a single API to access all these different disparate data sources that we talked about, the built-in algorithms to enrich the data, and then the visualizations, which I spent a lot of time talking about in this session.
Yeah. Oh, this is cool. So we are getting close to end of our time together. So I'm sure there's a lot of people watching this like, this looks really cool. How can I get started on this? Where should I go?
Yeah, thanks for that. We have our webpage, the SageMaker / Geospatial webpage. We have examples on GitHub. We also have 2 pre-built solutions ready to go. And I wanted to also just remind people of the quick getting started path we have for Geospatial SageMaker in the core steps that you need to get started. So it's super easy to get started. And we love to hear more from the use cases. I shared a few here. Love to hear some other use cases that people are working on.
Yeah.
Very cool. Yes. Yeah. Especially the visualizations, those are easy to understand. Even if you are not a ML practitioner, seeing it visualized is extremely helpful for sure.
Yeah.
All right.
Well, Kimberly, thank you very much for joining us. Any parting words before we've got to move on?
Well, thank you for the opportunity. That this is my first time joining the AWS On Air team, so really appreciate it. And my only parting advice is get hands-on, start trying it, because we want to hear from you what else we can do to make geospatial ML easier. Thank you.
Thank you so much, Kimberly.
Welcome
I hope
back anytime.
Yeah, I hope we see
Thank
you
you.
again.
Thanks.
All right.